So you've been working hard on your SaaS application and now it's finally ready to go live. But now you're faced with a big question. What's the best way to host it in production? Now, if your app is built as a containerized microservices application, chances are you have been using either your local machine or a single virtual machine with Docker and Docker Compose for development, testing, and maybe even staging. You already have everything defined in a Docker Compose file, the services, dependencies, volumes, and other configuration. So adapting your Docker Compose service definitions for production seems like the next logical step. So with just a few tweaks, you can deploy all your containers to a VM in the cloud and then just simply tighten up security, add external load balancers, and point a domain name to your server. Now, a single VM setup with Docker Compose may work for a while, but as your user base grows, you'll start hitting some limitations. You can't keep vertically scaling your VM's CPU and memory forever. Plus, a single server setup means a single point of failure. If your server or even the entire availability zone goes down, your app goes down with it. So you know that for production, you need something more robust. You need a platform that is highly available and most importantly, scalable, especially if you're expecting growth. And of course, running Kubernetes has probably already crossed your mind, but maybe you're hesitant of the added complexity and maintenance and admin work that comes with it. Well, what if I told you that there's a much simpler way to get some of the benefits of Kubernetes without the hassle of running a full Kubernetes cluster? Enter Docker in Swarm mode. Swarm mode is an advanced feature for managing a cluster of Docker daemons. It's easy to set up, it is great for production, and it provides high availability and scalability, which is exactly what your SaaS application needs. So in today's video, let's dive in and see how you can set up Docker Swarm on a cloud provider of your choice and deploy your SaaS application to production. So the first thing we need to do is to create 2 or more VMs in your favorite cloud provider. Now we need to ensure that Docker is installed on all the VMs. So you can follow the official Docker Engine installation guide from the Docker documentation. So once this is done, we're going to select one of the VMs to be the manager node in the swarm, and then we can enable Docker Swarm with the command Docker Swarm init. So this command is going to set up a new swarm, and then the output of the command will also generate the instructions on how we can join other nodes to the swarm. So we use this same command that is displayed here to join other VMs to the swarm. And once this is done, we can verify that the swarm is up and that the nodes are added with the command docker node ls. We can also inspect any individual node with the docker node inspect command. And then we can use the self keyword if this is a manager node, or we can use the node ID on any other non-manager nodes. So all management tasks are all going to be done on the manager nodes. And you can have multiple manager nodes for redundancy. So there are also instructions that you can follow. First, to retrieve the join command for managers, and then to join a new manager to the swarm. So let's recap. So now we have deployed Docker Engine on 3 VMs. We have enabled swarm mode and added all 3 VMs as nodes to the swarm. So now we can start deploying services. So a Docker service is an abstraction for running a container in a Docker swarm. It defines the containers to be run, the number of replicas to be created, and how they should be distributed across all the nodes in the swarm. So let's go ahead and create our first service. Now, because a swarm consists of multiple Docker engines, we're going to require a registry in order to distribute images to all of them. So the first service we're going to create will be the registry service. And you can create a service using the docker service create command. And then you can verify by listing all the services, the docker service ls command. So now we have all the necessary parts in place. We can deploy our microservices application as a Docker stack. Now, a Docker stack is a collection of services that can be deployed together. So we can define our Docker stack by using a Docker Compose file. I've already cloned the microservices demo application project onto the manager node. So this project has the application source code, the Docker files for building the images, and a Docker Compose file for building and running the application. So we can update the image names to use the local swarm registry service that we just created. Then we can run docker build to build the images, and then docker push to push them to the registry. And then now we can deploy a new stack based on this project, and we can do that by running the docker stack deploy command. In this command, we specify the compose file with the -c option, and then the name of the stack comes at the end. And then we can verify that the stack is created with the docker stack services command. And now we can use the docker ps command that we all already know to check all the nodes in the swarm for where the individual containers landed. So now we want to update our stack to take advantage of some of the swarm features like resource allocation, high availability, and scalability. So what we need to do is to update our stack configuration. And to do that, we can add any docker stack specific configuration in an override docker compose file. Docker stack configuration can be configured under the deploy section in the compose file. So to see all options of the Docker specification for Docker compose files, you can see the Docker documentation. So here we can set the number of replica containers that we want for each service. We can also set a restart policy, how we want the container to be restarted when it crashes. So things like the condition that triggers the restart, how much time is there between restart attempts, and what's the maximum number of restart attempts that are allowed. We can also set CPU and memory resource reservations and limits. And we can also restrict some containers to some nodes or even prevent them from being scheduled on other nodes. Now this is based on the labels which can be added to a node with the docker node update command. For example, I can add the database true label to a node I wish to only be used for the Postgres database. And then for the Postgres service under placement, I can set a constraint to restrict the Postgres container to that node. And to keep this VM clear of other containers, I can set the opposite constraint on both the API and worker containers. Now, Docker Swarm also has a feature that is similar to config maps in Kubernetes, and it's called service configs. It allows you to store non-sensitive information such as configuration files outside of a services container. So here in the config section, I am creating a new config called settings, and its contents will be what is in the .m file here in the same directory. And then the config can be mounted to a container by specifying it in the configs section of a service. We can also do the same for volumes by defining all the volumes required for each service, like you see here with these NFS volumes. Now, of course, you need to make sure you have an NFS server set up with these paths exported on the server. So we need some kind of network-based storage where volumes can be created irrespective of the node where the container is running. So now to update the stack, we can again run the docker stack deploy command. And this time we specify the additional docker compose override file with another -c option. So now we can run a few commands to verify the new configuration. Docker stack services command again shows the new status of the stack. You can see the replica count has gone up for the worker service. And you can visit each node again and see where all the containers ended up. The Postgres container is on the third node, which we labeled with database true. And we have no application containers running on this same node. We can also use the docker exec command to check if the config is mounted in the API container. We can also check that the NFS volume is also mounted in the same container. And now for external connectivity for your applications, you can simply direct traffic to the nodes in your swarm via a load balancer, for example. Docker's inbuilt routing mesh lets you access any node in the swarm on your application's port, and this will get you routed to the application. As you can see, getting started with Docker Swarm is both easy and fast. But of course, we've only scratched the surface. There's so much more to explore in terms of the features and the configuration options. Be sure to check out the official documentation and experiment with even more capabilities on your own. So thanks again for watching. If you found this helpful, please don't forget to leave a like and subscribe for more content like this. And I'll see you in the next one.